I will show you a couple of demos, one demo, just to make you feel at home and understand my point. Where is the downside? So here's the code, animating a circular view from point A to point B by setting the state every period of time and updating the relative position in order to move the view. It's really simple, it's really good. And if you have an application that only does this thing, animating a circle, you're fine. You have no problems. But in the real world, it's not. It's another issue. Because if we have like normal application that does a lot of work, like sending HTTP requests, they're having computational work, and a lot of side things that JavaScript have to deal with it. So this code in the right side does for the JS thread. Just every 1 second, do a couple of computations, and that's it. And that's it. Nothing fancy here. In the meanwhile, that code wants to animate the circle view here. So let's start. Let's showing what's happening. Ah, sorry. Oh, so I will show what's happening here. So what's happening is this really cool for you? No, it's bad user experience. It's not smooth. It's not good. But in some sort of way, let's start analyzing what we're doing here. What happens here? So first, a good assumption here. If you want to do animation, we're targeting 60 frames per second. If you do the math and the calculation, you find out that you have a window of 60 milliseconds just to do the animation and the other stuff. Sending HTTP requests, dealing with the response of that request, handling cache, exceptions, and more. So let's start see what's happening here. First, we set the circle at the beginning, then move it to the next position, it's fine. There's the stress job. That's the heavy computation. Maybe I'm talking to the native to compress me an image. Maybe I'm sending a request. There's a heavy work happening in that JavaScript thread. So what you saw with the animation that the circle stuck and then moves moves from for the next position where we didn't expect it to be, that called skipped frames. So what happened here in the red, while the JavaScript dealt with that heavy job, it just skipped a lot of frames. So when the animation continues to work, it will start from another position that's not supposed to be there. That's it. So that creates the lag and the unresponsive animation, not smooth animations that we saw. So how are we gonna deal with it? So we overcame this challenge with a little bit concept that we heard about. Maybe you heard about. Did you heard about declarative programming? Anyone heard? Hands? Yeah. So declarative programming. Let's see through what's declarative programming. It's really fancy words, buzzy words. So let's see what's happening here. So declarative programming says that, hey, send me the data. Let's imagine that there is an imaginary engine that does the animation. It's fine and good, working good. It's always smooth. And we send in the data. What's the data? It's the starting point, end point, and how the interpolating data, how the function of the animation. And that engine will do the work for us. And that engine has a name called main thread, where the UR is being drawn. So we send an event every 16 milliseconds from that thread, from the main thread to the main thread, which it's okay. It's synchronous, it's fast, it's instant. And while the JavaScript doing his job, their job, the main thread will take care of animating the view smoothly without any interruption. So Declarative programming, how are we gonna apply it? So there's a lot of options. Option number one, using the animated library of React Native. There's a feature called a flag called use native driver. You can set it through, but it's really limited for a basic animation. It's not customizable. It's really limiting our capabilities of doing animations. And you can go for third-party libraries. That's our solutions. You can go to for third-party libraries like Reanimated, Interactable, and more libraries, whatever you can, whatever fit your needs. And if you really insist of being customizable, fully customizable solution, you can write your own view manager, which takes a view. It's really simple. Takes a view, takes the data that we saw early, the starting point, the end point, pass it to the native, to that view manager, which is the native view manager, and we'll do the animation for you. I put here an example, a link to a repository at Wix where we show how things is done there. So this is the possible solutions that we got. So this is really was like not that tough example because we have a third-party libraries. People already done it for us, and if we have a really cases that we want to do custom, really fully customized stuff, we have the way to do it, and hope you will use it. Don't be afraid just to write custom view manager. It's really simple. It's not that hard, and you can do the animation natively. And it's the best thing to do is using already. Do not reinvent the wheel and use already in solutions. So since we are talking about JavaScript, we say that it's single-threaded. So we have one thread that talks to our main thread. So how is that possible? So all the data from JavaScript thread to the main thread must pass on Stairway to Hell. So this is the bridge. Welcome to the bridge. This is the way from the native realm to the JavaScript realm and vice versa. And who knows the bridge here? Who heard about the bridge? Hands. So the bridge itself is like a messenger. The simplest the simplest form of it is like a messenger. It takes the messages from one person, make some magic on it, and pass over to the next one. That's it. It's really simple. It's not that simple. But the bridge itself is asynchronous. We have one thread that dealing with JavaScript code and one thread that is dealing with the native code. So how things is working? Let me show you a couple of demos. I love to showing people demos because it's real life. It's not just theories. So let's jump on for this demo. So what you see here, it's a native Android application written in Java, not JavaScript. And here's the business logic. It just takes a phone number and applies some business logic by formatting it, and adding a dash after the fourth digit. So it's smooth, yeah, right? It's good. It's fine. Nothing wrong here. Excuse me. So the whole business logic and the whole showing the numbers on the screen is happening with that main thread. So nothing wrong with it. What about React Native application? Can you spot anything wrong? Can you spot? Did you spot it? How many spot the issue here? So this challenge we are facing like for every day because in a real application or in the on a Android device like 5 years old, that's how it performs. The newest devices, it's the same story, but it a little bit different. So what's happening here? So first of all, the user press on the number. It happens on the main thread on the native side, The native side, since it edit text, it will show it right away and sends the message to the JavaScript thread. Say, hey, I have something changed. Do the business logic and return to me. Format it and return to me. So since nothing to do here with the format, the result is the same as what is shown on that edit text view. So let's continue with the demo. After the second number, it's okay. The third number, it's fine. And the fourth number, we have the issue. So what's happening here? The fourth digit got printed on the screen. We take that number, send it to the JavaScript thread via message via the bridge. It takes time since the bridge is serializing the message, deserializing it in order to JavaScript to understand what the message. And after that, we are applying some business logic here in the JavaScript thread, and we got the result back. So, a fraction of time, the user sees these these two values, these two final results, and we don't want that two final results. So actually, it goes on, and that is really bad user experience. So I'm gonna share with you another real life example with the same issue. This is the Wix application where you can enter credit card. Did you spot the issue? So beside from loading the knowing the logo of that credit card and limiting the numbers and doing that business logic is happening on JavaScript. So put in mind that each time you press a button, it will travel to the JavaScript thread, have the logic applied to it, and sends back. You have a couple of milliseconds, and you have to do it in 16 milliseconds if you want to. Keep in mind that you have to do it in 16 milliseconds if you want to achieve really good animation and smooth application. So let's see another example from the Wix application. Lists. We love lists. How many of you faced this issue in their life? How many of you try to solve it and hey, I'm the next Einstein, I will do synchronous list? No one. So I tried at the first day, I think, Liv. First day I tried, hey, I can do it. So I didn't know that there's a bridge. So what's happening here? I will explain it in a really simple way. What's happening here? The scroll happening on that main thread. At the beginning, the main thread receives a message that hey, I'm going to show here like a lot of like 1 million items. Be prepared, and it will prepare a space for it. And afterwards, after each scroll, the mechanism works like that. After each scroll, native side talks to the JavaScript side. Hey, give me more that I want to draw, and it takes time. Maybe the JavaScript side is busy doing BI event. It's sending an request, and I don't know, maybe it's loading another module. So in the meantime, nothing is shown as blank screen, blank items, white items. So what is going on? So this issue actually hard to figure out. So how did we overcome it? So you have a couple of solutions. First, declarative programming. So moving the business logic to the native side, if it's possible. Moving to there, it will save you a lot of headaches. And it's not that hard to move the business logic to there. Maybe writing your custom views in their native and put that native logic and view there. A good use case if you want to show a gallery of photos. There's a lot of doing there. Loading the images, putting the grid, resize them, and then do the work. And the other thing that Terry will talk you about in the next talk is using the new JSI JavaScript interface Fabric turbo models that will replace the bridge maybe, and Terry will elaborate about it more. So here you go. we have our possible solution for this issue. At Wix, we use the first two solutions right now, and the last one, it's experimental. We're doing experiments on it. It's not final, but there's one more thing. Remember, I talked about the documentation that I missed, that we have someone called Hermes. And Hermes is a new JavaScript engine which will replace the JavaScript core hopefully soon. And what is special about it? It's really mobile first JavaScript engine. It's not for the dedicated for the web. It's not dedicated for other things. It's just mobile only. So what it's doing in a nutshell is taking the JavaScript code, compile it, taking that stages that was in the runtime into the build time. So what does it mean? We're minifying, parsing, compiling the JavaScript code at the build time. We have a lot of time at build time. You can drink a lot of coffee. And at the runtime, just execute it like any other application. It's just a binary code. That will help you make faster startups in the first place. And it will take care about it will not load the whole binary file. That's that's the main thing. So we hope it will be soon, and Terry will elaborate with you about it soon, really soon. So thank you, and have a nice evening.